equations. First of all, let's take a quick peek at what a system of equations is. Graphically, what happens if I graph two linear equations on the same coordinate plane, then I most of the time will get two lines that intersect. They intersect in a single point, and that point has an x and a y value. So it's the location of the point. Think about if we were solving the equation 2x minus 13 equals 21. And we got down and we had an answer of x equals -5. If we wanted to see if that solution worked, if we actually had found the right answer, we could go off to the side and solve this equation again and see if we got the same thing, although maybe we made a mistake and we made the same mistake again. The other way to do it is to say, well, if x is -5, then I'm going to go back in the equation, and where I see x, I'm going to substitute -5 and see if both sides of the equation really are equal. So to check my answer, I would say 2 times -5 minus 13 and say, does that really equal 21? Well, -10 minus 13, is this side. This side ends up equaling -23 when I substitute x in, and the other side is 21, which means the solution is not x equals -5. If instead I had gotten the solution x equals 17, and I wanted to check that one, I would have said 2 times 17 minus 13, does that equal 21? Well, 2 times 17 is 34 minus 13. So 21 on that side, 21 on that side. You know what? The thing that makes this a true statement only works if x is positive 17. If it's anything else, I'm going to get two sides that are not equal to each other. So I could solve it from scratch and see if I got the same thing again, but I might make a mistake in solving it. Or I could just substitute the answer back into the equation and see if I get both sides of the equation equal to each other. That second one is what we're going to do on these. Inside an ordered pair, I have an x value and a y value. I'm going to go to each of these equations. First, I'm going to start with y equals 47 plus 3x. I'm going to substitute 0.2 for the y. Be careful what you substitute where. Some people just, the first variable they see, they put in -15.6. That's your x, not your y. So equals 47 plus 3 times -15.6. So 0.2 equals 47. 3 times -15.6 is -46.8. So plus a -46.8 is like -46.8. I could also just, once I substitute this, I could just plug this whole side into my calculator and hit equals and see what I get. 0.2 equals 0.2. Which means this point is on the first line. Don't stop there, because if you stop there, what you may have found is a point like this. It's on one of those lines, but it's not the point of intersection because it's not on the second line. You have to, if it works in one, you have to check it in the other one. So I'm going to take my y equals 8 plus 0.5x, but y is 0.2 equals 8 plus 0.5 times x, and x is -15.6. Again, if you don't want to do any steps between here and the end, that's perfectly fine. You could just grab your calculator and punch in 8 times 0.5 times -15.6 equals, and you get, 8 plus 0.5 times, and you get 0.2. So this side is 0.2. When you plug this side in the calculator and you have to show this substitution step, you get 0.2. Hey, it works in that one too. So it is a solution to the system. It's not just a solution to one of the equations. What we found is really the point of intersection of the entire system. So I'm going to go to the first equation and substitute my x and my y in and check it. So 2 times negative 4, and you have to show this step, plus 23 equals 15. I'm going to put a question mark because I'm checking to see if this is true. You can now just punch 2 times negative 4 plus 23 in your calculator, and you get 15 equals 15. Yep, it's a solution to the first one. But remember, if you only check the first one and it works, you might be finding a point like this instead of the point of intersection. You have to show it works in both of them. So y is 23 for the second equation equals 12 plus x is negative 4. And I'm seeing if this is true. 23 equals, well, 12 plus negative 4 is 8. No. Don't leave it here. Answer the question. Is not a solution. It's a solution to one of the equations, but it's not a solution to the system of equations. A system of equations has 2 or more equations in it, and the solution has to be a solution for all of them. Now, if you had checked the second one first, as soon as you found that no, you could put is not a solution. You don't have to check the other one, because once it doesn't work in one of them, it can't be a solution to the system. So again, substituting into my first equation, 12.3 for the y equals 4.5 plus 5 times the x, which is 2. And I'm saying, is this true? So this side is 12.3. This side ends up being 14.5. No, it doesn't work in the first one. If it doesn't work in any of them, in either of them, it's not a solution. So is not a solution. As soon as you know that on one of them, if it's the test, I'm going to double check my calculation and make sure I did it correctly. But as soon as you know it doesn't work in one, it's not a solution to the system. Now please pause this for just a minute and see if you can do this one on your own. And once you've done that, start the tape again, start the video again, and check your answer. So again, this is x and this is y. Going to my first equation, negative 4 times x is 1.5 plus y is 0.5, and I'm checking to see if that equals negative 5.5. If I just plug this in my calculator, negative 4 times 1.5 plus 0.5 is negative 5.5. The other side's negative 5.5. So that is a solution to that line, to that equation. Check it in the other one. My y is 0.5. Negative 3 times my x is 1.5 plus, not equals, plus 5. So I end up with 0.5 equals, and again, plug this in your calculator all at once if you want to. 0.5 is what you get. So this is a solution. You need to both show the substitution and the simplification on these, and you have to have the answer on this. Thanks, guys.